All right, welcome back, everybody. We are going to go and do our daily algorithm of the day. So this past Monday, we went over divide and conquer, um, and we haven't really touched up on the algorithm or really gave you guys much chance to actually implement it during any of our sessions. So we're going to go ahead and actually give it a try. This lead code problem is almost exactly similar as the one I used for the demonstration. So this will give you a nice little warm up to give it a try and see how it works. So tomorrow you can do it a little bit more difficult version of it. I'm gonna go ahead and drop the link in the chat. There we go. And let's actually kind of talk through this real quick. So we have a hot mic. I don't know who that is, but just heads up. So sort an array, right? So we are given an array of integers, essentially numbers within a list called nums, right? And we have to sort the array in ascending order and return it. We must solve the problem without using any built-in functions, right? Uh, in O n log of n. Well, luckily for you, the merge sort algorithm is n log of n, time complexity, and with the smallest space complexity possible. This is a medium problem, so we are advancing a little bit more. And if you guys try to look up any kind of solutions for merge sort, most of the solutions you're going to find all involve recursion. We are not using recursion for merge sort until tomorrow, because recursion is the algorithm for tomorrow. Once we learn recursion, we can actually use it for our merge sort. But as of right now, we are going to use it the same way that we did on Monday. We see here that we have an input of integers within a list. And then the output is all the order or all the numbers that were given to us in ascending order from 1 to 5. All right. Explanation: after sorting the array, the position of some numbers are not changed. For example, 2 and 3, while the positions of other numbers are changed, for example, 1 and 5. That's because that's the correct order that was supposed to be. And then we see here the same on example 2. We have from 5 going to 0, and they were able to format them as needed. Our constraint is that the length of our list would not be anything less than 1, and it'll not be greater than whatever this ridiculous number is. All right, but we know that we have to check that it does not equal a certain number like 1, and if it is, we should just return 1, right? Because it can equal 1, but it won't equal 0 or anything less. So if the length of the list is 1, then that means it should be sorted, and we can return that because only one number. And then it gives you an explanation of the constraint of what the numbers within the array are. I'm not going to attempt to even write out this number, but it does tell you how big they can get, right? So when looking at this problem, we have a couple things to take into consideration, right? First thing is my list equal to 1, right? Or is the length of my list equal to 1? And if it is, then we should probably return our list because that means it is sorted and we don't have to go into the rest of our algorithm. And if you recall the algorithm explanation on Monday, the way that we started off was by creating the length of a sublist. We want to divide our problem into smaller components, right? So we essentially made a big list of lists with only one item in it. So we'll probably want to create the length of our sublist to track our sublist. We had an outer loop to track length of sublist to be less than the length of our list. Once the length of our sublist is equal to the length of our original list, what that tells me is that all my individual problems have been sorted and merged together to the point where I'm not comparing two different lists to see which one is less than or greater. Right? So I don't have to sort anymore. Therefore, it is the size of my original list, and I can return it from here. The next thing to consider is once we track the overall outer loop, we need to create a for loop to track the actual merging of our lists. Right? In this for loop, there's some things I had to consider. The start should begin at 0. The end should be the length of my list. And I need to consider the length of my sublist, right? My length of my sublist is to be doubled after every iteration. Because every time I'm looping through and organizing things, I am merging two lists with one index together. Therefore, going from one item in the list to 2 items and then 3 items. And these lists are just getting bigger and I'm having less lists overall, right? I believe I have it somewhere here, right? At one point, I will have a huge list of just lists of individual numbers. The first time I go around, my sublist should be the length of 1, right? These are my sublists. 1 sublist, 2 sublists, 3, 4, and so on. When I merge them together, the length of my sublist needs to increase because now I have 2 items within a sublist. And every single one afterwards as well is being merged. So the next time I loop through that array, I need to take into account that my sublists have increased. So I multiply that sublist by 2, which takes into account the increase of my sublist length. I should also create a helper function to handle the merging, or I apologize, not the merging, the sorting, right? The sorting of my sublists. So you remember we had the merge sort, the overall function, and then we had a merge function that took these individual functions, or not functions, our individual sublists, it grabbed them together, right? And then compared them between each other to sort them and then return them to me. So create a helper function to handle the sorting of my sublist. Then I merge my sorted sublist to my original list. And finally, return my sorted list. All right, this is a very down and dirty of the steps I should probably take that resembles very similar to how we explained it on Monday. Time is 4:10. Let's go ahead and reconvene at 4:20 and give that your honest try. All right, hopefully you guys were able to give it an honest try. So, before we went off, we talked about how we would tackle this, right? And we're going to take this one by one. The first was to check if my list was equal to 1, and if so, return that list, right? So within here, we're going to say if the length of nums is less than or equal to 1, then return nums. And in the event that it is, we don't have to move forward with the rest of the algorithm. The next step was creating the length of a sublist to track our sublist throughout the entire algorithm itself. So we say sublist length is equal to 1. Right? On top of that, we also need to know the length of our list so we know how to compare our sublists against it. So we say nums length is equal to the length of nums. So we have our starter, and we have the total length of what our list should be. The next step was to create an outer loop to track the length sublist against the actual list itself. So then we say while sublist length is less than the nums length, then I should do the following. So while sublist does not equal length of nums, continue merge / sort, right? This is our outer loop that'll keep track of the entire process. And now we actually want to loop through and build our sublist. So we say for I in range, we are going to start at 0. We want to go up to the total length of our list. So we use the nums length variable we've gotten. And we should be skipping the size of our sublist length, right? That'll create our individual sublists in accordance to the divide portion of divide and conquer. And as our sublists are getting bigger, right, as we increase the size of our sublist, then we have to multiply that by 2 to take into account that we have 2 different arrays that we are constantly pitting against each other. Now we are going to define the left and the right subarrays to compare and merge. So we say left is equal to, we're going to do nums, we'll grab the list. I want to grab everything from index I, which is at the very first time we run this, it's going to be 0, up to I plus the size of our sublist length. So just like the explanation for Monday, they should essentially return to me. If we were using this one right here, the left will end up being 5 and 2. And for our right, we want to grab I plus the sublist length. All right, essentially what we did here on the right side, we were doing the same, but for the left side of our slice. And then we want to get up to I plus 2 multiplied by the sublist length. And this will grab me 3 and 1 from this example. Right? Now, the next part of this was to do the comparison of our left and our right subarrays. Right? So we probably want to actually make our helper function before we move forward. Within here, we are going to say define merge. This will do the merging for us so we don't add all the functionality within our main function. We're going to take a left subarray and a right subarray. We are going to create an empty array that we will add the sorted portions of that subarray, right? So where are we in this step? We create the outer loop. We create a for loop to track the actual merging of our list with the start endpoint and then the step argument within the range. And we are currently creating a helper function to handle the sorting of the sublists. And then we say we could do I is equal to 0 and j equal to 0. Or we can do something like I equals j equals 0, which is the exact same thing. Let's just do this so we know exactly what is what. But essentially what we did here is create our left or our pointers for our left and our right sublists. So we can track individually both sublists of what's being sorted. And then we do a while loop in here that's going to do the sorting of our lists. So we say while I is less than the length of left and j less than the length of right, we want to sort. If in the event the number at index I is less than the number at index j on our right sublist, then we want to add index I from list left into our sorted array. So we append that number. All right, so what is this doing? Well, we have the two sublists. For our first example, we have 5 and 2, and 3 and 1, right? Both I and j are set to 0. So both of these are pointing to the first item within this list. And it compares it, right? Right here. It compares it on line 28. If I on the left subarray is less than or equal to j on the right subarray, then I want to add I into the sorted array. And that's not going to be true, obviously, because 5 is bigger than 3. So we have to take into account what happens if right is bigger than left. Right? We say else sorted array dot append right index j. After it adds whichever one is left into our sorted array, then we need to move that index to track the next number within that list. So we say I plus equals to 1, and we do the exact same thing on the other one where we increase j instead. During Monday's explanation, you saw me do something where I did while I is less than the length of left, continue to append into the sorted array the remainder of that list. When I tried doing this in LeetCode, it yelled at me, right? Because there was 3 different while loops in here, and it said maximum time like exceeded. So I had to change how I did this. And the way that I fixed it was by grabbing the sorted array and using the .extend method. Essentially, just added things to the right side of the array. And what I'm adding to it is the remainder of what was left within the left array or the right array. This is J. Finally, this returns our now sorted array. We can come back to our main function and we say nums I plus the length of left plus the length of right is equal to self.merge left right. Well, what am I doing here? Essentially, I am grabbing the now sorted array and adding it to the remainder of my original list, right? Because we have a portion of that list already sorted. Well, now we have to add it back to the original. And that's what this is doing, right? It's grabbing here for the first example, it'll say 0, 0 plus whatever the length of left is. So essentially this is 2 plus the length of our right, which is also 2, therefore being 4. Right, we can remove this. This is saying, hey, everything from index 0 to index 4, I want that to equal the now sorted array. Right, so essentially this gets added to the very front of the array because now this is sorted. We don't need to worry about that. Right, after that gets added to our original list because it's sorted, we go ahead and increase our sublist length by 2, and we finally return our sorted list. Sublist length starts at 1. After the first iteration, we multiply it by 2. So this now becomes 2. The second time it comes back into this, sublist length is equal to 2. So it gets multiplied by 2, making it 4. And now the next time this runs, the left is equal to index 1, 2, 3, and 4. And the right is index 5, 6, 7, and 8. Right? Mocking the functionality of increasing the size of our subarrays. And then repeating that process until eventually our sublist length reaches the size of our original array. I'm going to go ahead and stop the recording now.